Welcome to great students. இன்னைக்கு நாம welcome to great students. Today we are going to discuss 18th Welcome to great students. Today we are going to discuss 18th April 2021 exam happened, which was conducted by UPSC. This NDA exam has been happened twice a year. This is the first session, NDA 1, 18th April. That is the last Sunday it happened. Now we are going to discuss a mathematics paper particularly. So we will do the sum. First question. So it is given, it's a general mathematics. 120 questions they are giving in NDA mathematics paper. 120 questions conducted by UPSC. So we know the standard, and that too is a general mathematics. So we must know the concept very clearly, and we must have lot of practice in that particular every chapter. Then only we can get the very clear-cut idea of the question, and then we can answer it very easily. Okay, it will not take much time, but we must know the conceptual clarity before doing the sum. Okay, we will start the sum. You know that everything. So first sum we will start. Tan inverse of x plus cot inverse of x is equal to pi by 2 holds when. That means for what values of x this equation is satisfied. This is a property of inverse trigonometry. So we can do many sums by using this property very easily. Otherwise it would have taken lot of time, but because by using this property we can do the sum very easily. But the question is what x belongs to for this properties to be satisfied. So you might have we have two other formula also the similar pattern, that is sin inverse of x plus cos inverse of x equal to pi by 2, secant inverse of x plus cosecant inverse of x equal to pi by 2. That all you know that. But in this which limit x value, that thing is there. So for that we will go to the proof. This is a property. I'm just going to prove this property. If I'm just assuming theta equal to tan inverse of x, I can move tan inverse to left side, so it becomes tan theta equal to x. Now I want tan and cot to prove it. So I'm just changing this tan to cot. To change it, I'm writing tan theta as cot of 90 minus theta. Now I need cot inverse, so I'm just moving this x to this side. So cot in now this 90 can be written as pi by 2, so it becomes cot inverse of x equal to pi by 2 minus theta. Now in this theta I can substitute tan inverse of x. I just assumed this as theta. With the help of this theta I found cot inverse of x. So inside theta I'm just substituting tan inverse of x. So I will get the equation like this. So cot inverse of x plus tan inverse of x equal to pi by 2. This implies that this x is applicable for any real number. So while proving, we are not having any problem at all while solving, while proving it. So x's domain is any value you can substitute. Okay, that means x belongs to a real value of any real value you can assume. Okay, so for x, so we can take option A is the right answer for this. Okay, next we will move on to the second question. So the second question from trigonometry. That trigonometry sum is actually very easy sum. This is a very repeated pattern. In every competitive exam they ask this type of patterns, giving one function of trigonometry and then asking other functions values based on that. And that too, this is based on cos 2a formula. So everybody, whoever may be, if you are preparing competitive exam, you must know the cos 2a formula in all the forms. So cos 2a, we know cos square a minus sin square a. Even you can write it as cos power 4a minus sin power 4a, and cos 2a is equal to 2 cos square a minus 1. Otherwise 1 minus 2 sin square a, and another form cos 2a is 1 minus tan square a by 1 plus tan square a. So in the cos 2a itself we have 5 formulas almost. So you must know all the formulas. They will ask every question, every exam one question they are asking. So they have given tan a directly. So from that we have to find cos 2a. Okay. So directly we can substitute. Tan a is 1 by 7. Tan square a will become 1 by 49. Right. So 1 minus 1 by 49 by 1 plus 1 by 49. Now we can just simplify this very easily. 1 can be considered as 49 by 49. So 49 minus 1, 48 by 49. Here same 49 plus 1, 50 by 49. Now denominator 49 cancelled. So 48 by 49, when you cancel with the two table, you will get 24 by 25 as a right answer. Okay. So 24 by 25, option A is the right answer for this question. Now we will move on to next question. That is third question. Before moving to the third question, please subscribe and like our channel, and through your like only YouTube will understand that the content is good, so that the YouTube search engine will suggest our video for many people. And we are going to do a lot of videos for UPSC and many competitive exams. So it will be useful for you if you are helping supporting our channel. So please like our video, and if you are not subscribed, please subscribe immediately and press bell button, so that immediate notification will be coming once we have come to the live. Okay, now we will move on to third question. So consider the following statements. So this question from set language, it is given that A equal to 1, 3, 5 and B equal to 2, 4, 7 are equivalent set. Okay, they have given first statement as equivalent set. What do you mean by equivalent set? An equivalent set is simply a set with an equal number of elements. So if there is equal number of elements, the set do not have to have the same exact elements. Not necessarily elements should be same, but number of elements is equal, means that is equivalent set. Okay, here 1, 2, 3, 3 elements are there, here also 3 elements, but elements are different. So definition is same thing, equivalent set. So first statement is true actually based on our definition. Second statement we will look at 159, here 15599 is equal sets. What they mean? Two sets that have the exact same elements, we call them equal sets. If there is same elements, then only we call them as equal sets. Now in this question we have 3 elements looking, here we have 5 elements. Immediately we may think that elements itself not matching, how can it be equal set? But look into very carefully set B. In the set B, look at this. The 5 is repeated 2 times, 9 is repeated 2 times. In the standard form of set language, we never repeat any elements in the set. Okay, we always write set only once. Every element will be appearing only one. So 55 will be written only once, and 9 will come only one. So actually the standard form of B set is 1, 5, 9 only. Here also 1, 5, 9. The 3 elements also there, and number of elements also 3, and also every elements are same, exactly same element. Okay, it's given same elements 159. So this is a equal set. This statement 2 also true. Okay, so from this we can conclude that both the statement 1 and 2 are true. So for this question, option C is the right answer. Next we will move on to the next question. That is the fourth question. Let R be a relation defined as X related with Y. Okay, X or Y means X related with Y. If and only if 2x plus 3y equal to 20. So in the set language, what they are telling, X related with Y means X and Y, the two sets are there, they are related with each other. At the same time, it has to satisfy this condition, 2x plus 3y equal to 20. And one more condition is given, X comma Y belongs to natural number. So read the question in depth and note the point so that you can solve easily. The sums will be easy only. But the only thing is you have to be read carefully. That's it. So X comma Y belongs to natural number. It is given, right? So we have to choose a natural number such a way that 2x plus 3y should be equal to 20. So I just do the trial and error method. Natural numbers start with 1, right? So I substitute x equal to 1. So it becomes 2. Here what we will get 2 means 20 minus 2, 18 will be there. So I will get 3y equal to 18 from this, y equal to 6. So when x is 1, y should be 6. So 1 comma 6. So this way it is related. X related y related with y. 1 comma 6. This is one element, one pair. Form of x comma y they are asking. How many elements we will get? So one element I got. Another trial and error. After next I can try 2. It's a natural number. No other choice. We have to do that. Trial and error only. So if I substitute 2 into 2, 4 I will get. But remaining is 3y has to be 16. So y cannot be natural number, so that 3y will become 16. So x equal to 2 is not possible. If I have substitute x equal to 3, what will happen? It will become 6. Here I have to get 14. So 3y 14 means y cannot be natural number. It has to be fraction. So it is not acceptable. We need natural number. So this is also not possible. When I substitute x equal to 4, what will happen? It become 8. This will become 12. So that means 3y equal to 12. 3y equal to 12. When I substitute x equal to 4, here 3y equal to 12 means y equal to 12. That means y equal to 4. Again 4 comma 4. So 4 related with 4. So 4 comma 4 is another relation satisfies. And the third one I can try 4. I tried, then I could try 5. It becomes 10 means 3y cannot be 10. And when I substitute 6, it becomes 12. And it is 12 means it has to be 8. So it is not possible. And if I substitute 7, it becomes 14. So to be 6, y should be 2. Okay, y should be 2. Y equal to 2. That means this is 7 comma 2. So we have 2 pairs. And 8 will not come. 9 also will not come. You know that. But we can get 10. You can try 10. 10 comma 0 you can try. It becomes 20 plus 0. But 0 becomes what? It is actually a whole number. It is not a natural number. So that what we have to do? We have to eliminate this. So only 3 sets which satisfies 2x plus 3y equal to 20 as well as x comma y belongs to natural number. So we have to choose option B as a right answer. So there is 3 elements x comma y format, right? So option B is the right answer. Next we will move on to the fourth question. In the fourth question, what is given? It's a fourth we completed. The fifth question. Consider the following statements in the respect of arbitrary complex number z. Okay, you can take any complex number z and consider the two statements. Which are the statements follows and not follows, like that questions are coming. Okay, the first statement: the difference of z and its conjugate is an imaginary number. A complex number and its conjugate, we have to find the difference. So it will give imaginary number they are telling. Let us check it. Let me assume z equal to x plus iy is a general standard form of complex number. I'm just finding z bar. Z bar means we will change the sign of the coefficient of imaginary part. So y become minus y, so it become minus iy. Z bar. So what's the first statement say? The difference between complex number and its conjugate is imaginary. We will check it. Difference means we have to subtract one from other. So first I have to z minus z bar. So x plus iy minus of x minus iy. Okay. So when minus goes inside, it becomes minus x plus iy. Though this plus, no, minus x plus x cancelled. So this plus iy and plus iy, 2 iy we are getting. So when I get 2 iy, when I add up, I will get plus 2 iy. Iy plus iy, I will get 2 iy. So z minus z bar is 2 iy. This is right. 2 iy is an imagined number, right? Okay. So the statement also says like that. It's an imagined number. So it satisfies. My question is, why should be z minus z bar? Why can't it be z bar minus z? So I check another case also. I'm taking z minus z bar. So z bar is x minus iy minus x plus iy I'm doing. When minus goes inside, become minus x minus iy. Now x minus x gone. So minus 2 iy will be coming. So this is also imaginable. So z minus z bar or z bar minus z, both the difference gives the imagined number. So the statement 1 follows without any doubt. Next statement, the sum of z and its conjugate is a real number. They are telling z and its conjugate is a real number. So I take z and z bar. I'm just finding add sum. So x plus iy plus x minus iy. Now plus iy minus iy got cancelled. X plus x to x, which is a real number. So it is addition. So z plus z bar or z bar plus z, it is not changing anything. So I can take one case, only one is that. So it is a real number. This statement also true. So both the statement 1 and 2 follows. So for this question, option C is the right answer. Next, we will move on to the next question. What is the modulus of the complex number? I power 2n plus 1 minus I whole power 2n minus 1, where n epsilon natural number, comma I equal to square root of minus 1. Okay, I equal to, it's iota, it's a root of minus 1 means they are telling it is a complex number. That's all. Now we have to simplify this. Modulus also, please note this modulus point. Most of the people may miss this modulus word. Use this while answering. You have to consider this word also. Okay. Okay. Now we will simplify this portion. So I have rewritten this question part. Now base is a plus I here minus I. I just want to write in the same format. So that I have removed this minus from here. Okay. To remove minus, I have written separately. this, when I take minus 1 power 2n minus 1, it goes out. So then it becomes I power 2n minus 1, here I power 2n plus 1. So when base equal, I can add the powers. So I power 2n plus 1 plus 2n minus 1, I can just add them. Now what will happen? This plus 1 and minus 1 will be cancelled. So 2n plus 2n, it will become 4n. So I to the power 4n I will get. Here minus 1 whole power 2n minus 1. See, n is odd or even. Okay, n is odd or even. What will happen? Look into this. Here, when n is odd, they have not told anything about n is odd or even. Okay, number where n is a natural number, they are given. So we don't know odd or even. When it is odd, what will happen? Twice odd value, it will be even value. Even number minus 1, it become odd number. So the minus 1 power odd number will give the minus 1 as an answer. Okay. So this minus 1 will become. So here I said it is 1 plus 1. So 1 into minus 1 minus 1. This is one case. Okay. Another case we will consider when n is even. When n is even. When n is even, what will happen? 2 twice n. Even number 2 into 14 will be 28. So when you multiply even number, we will get again 2n will be even. Even minus 1, it is odd value. So minus 1 power odd value, it will give minus 1. So 1 into minus 1 is minus 1. So anyway, it's going to give minus 1. Now they are giving modulus of that. That means, what do you mean by modulus? See, this minus 1 can be marked on the plot, the graph as the real part minus 1. Here the point will be coming. Okay, this point as actually minus 1 comma 0 I. This is a point. Okay, now this is a point I have marked. Actually this is a minus 1, and the result we got. Modulus means actually the absolute distance from the origin. Always modulus, what it means? The distance from the origin. How much is the distance? This is a 1 unit distance. So we can write modulus of this value is 1. Otherwise we can use a modulus formula. What is square root of x square plus y square? Here x is minus 1. So when you substitute minus 1 whole square plus 0 square. So you will get root 1, that is 1. So anyway, answer is 1 is a modulus of this. Note this point. So we cannot put minus, only positive value we have to put. So option B is the right answer for this question. Next we will move on to the next question. That is the 7th question. If 1 root of 5x square plus 26x plus k equal to 0 is a reciprocal of other. For this quadratic equation, 1 root is the reciprocal of another root means what is the value of k? That is a question, right? See, generally in any quadratic equation, 1 root is reciprocal of other. That means the ax square plus bx, that is ax square plus bx plus c equal to 0 format means always a equal to 0. When a equal to 0, we can directly say that 1 root is a reciprocal of other. Always, we will prove it. That means when a is 5, c is also must be 5, so that we k equal to 5. Theoretically, we can finish the sum fast. Option C is the right answer. Otherwise, we know that as usual, I said now, when 1 root is reciprocal other means alpha into beta become 1, right? For example, 7 into 1 by 7, it's going to be give 1. So that product of roots will become 1 root of reciprocal of other. So alpha beta equal to 1. Now what is the formula? We have alpha beta equal to product of root equals c by a. C by a equal to 1. That is the meaning. So when c by a equal to 1, that means we will have c equal to a, correct? When c by a equal to 1, that means we will have c equal to a. Okay. So in the next question, here c by a equal to 1, so it becomes c equal to a. That's what I said theoretically. Always c and a will be equal. From this only I said. So in our sum alpha beta equal to c by a means k by 5 equal to 1. So now we will get k equal to 5. Okay, this is a straight sum. Next question we will move on. That is 8th question. In how many ways can a team of 5 players be selected? From 8 players, so as not to include a particular player. Okay, how many ways we can team of 5 players? So out of 8 players we are choosing 5, but condition is a particular one player is not to be selected. That means out of 8 we are going to eliminate one person. That means only 7% we are going to consider with selection process. So so that 7 out of 7 only we are going to select 5. One person not at all included in the selection process. So we can form a 7C5. It's coming in a combination, right? So number of person, order of occurrence will not affect, change the team. So A, B, C, whatever the order you choose, you are going to get the same team, so that it is coming in the combination. So we'll choose 7C5. So what is the formula? NCR equal to NC N minus R. Formula we know that. So 7C5 can be written as 7C7 minus 5. So it becomes 7C2. So 7 into 6 by 2 factorial 2. So when you cancel this, 3 into 7, 21 teams we can form from this satisfying this condition. So option C is the right answer for this question. Next, we will move on to the next question. That is, before moving on to the next question, please like our videos. So when you like a video, then only YouTube will suggest for the more people, so that our video will be reaching a lot of people. So please help us by liking our videos and subscribe our channel and press bell button, so that you will get the notifications once we come to the live. And we will move on to the next question. The next question is from binomial theorem. What is the coefficient of the middle term in the expansion of 1 plus 4x plus 4x square? Okay, this is a clear-cut find binomial theorem question. It's a very easy question. You can do it very easily. Now 1 plus 2, we say binomial, but that is given as trinomial. 3 terms are there. But we have formula only for binomial. That means only 2 elements should be there. So we'll make it into the 2 elements. For that, I am just applying the formula. A square 2ab plus b square. So it is 2x whole square, this 1 square. So it becomes 1 plus 2x whole square. The whole power 5 is outside. So power and power, when I multiply, I will get 1 plus 2x whole power 10. Okay. Now, in this 1 plus x whole power 10, general formula I am writing. 1 plus x whole power n formula is nc0, nc1 x power 1, nc2 x square, nc3 x cube, nc3 x power 4. Like that, it will be keep going. It is nc2 x square. Now, instead of x, we have 2x. So 2x power 1, 2x power 2, like that, 2x power 10, it's keep going. Now, in this, they are asking middle term. Coefficient of middle term. Say how many elements will there? Power is 10, there will be 11 elements. Why? You look at the 0, 1, 2. So when you write 0 to 10, there will be 11 elements. So if there is 11 elements, middle value will be definitely 6th term. So 6th term is a middle term in the 11 terms. So general T 6th term, we look at this. In the first place, here 0 will be there. Second place, here 1 will be there. In the third place, 2 will be there. Here 2x power 3. Whatever the power value comes here, same power will be 2x power. So that T6 will be 1 value less for R. So 10C5. Here 2x whole power 5, right? Location. Since third place 2 occurs, so 6th place 5 occurs. That's it. So now we know the coefficient means we don't want to consider x. Without x, we just find the value. So we will get the answer. Now 10C5. So down 10 5 times I have written. Denominator 5 factorial into this 2 power 5. So we are just writing only coefficients. Now we can cancel this. 2 5s are 10. Okay. Then 3 3s are 9. Next 2 4s are 8. Next what we will get? So 2 into 3 6, 6 into 6 36 into 7. Here again we will get 2 power 5 32. So we can just multiply 7 into 36 is 252 into 32. So 3 into 252, it will give 7560. 2 into 2 to 504. When I add up, we will get 8064 as an answer. It is easy sum we can do. So option A is the right answer for this question. Next we will move on to the next question. That is a 10th question. 10th question also the complex number based question. The smallest positive integer n for which 1 minus I by 1 plus I whole power n square is equal to 1. It is given like that. Okay. Now I is a square root I equal to square root of minus 1. So it is a complex number. Now we will just simplify this part first. Base value. Rationalize this. We will simplify this as much as possible so that we will get easy. So first I am just taking, I have taken to rationalize the denominator. I multiply conjugate of 1 plus I, multiply and divide with 1 minus I. So if this a minus b whole square, 1 minus I whole square, denominator a plus b into a minus b, so a square minus b square. I square is minus 1, we know that it is clearly given. I equal to root minus 1 means I square equal to minus 1. So when I substitute minus 1, so minus of minus it becomes plus 1. So a denominator will become 2. Here a minus b whole square, a square, this is b square minus 2ab, minus 2a. I square is minus 1, so plus 1 minus 1 cancelled, minus 2i is left. Now minus 2i by 2 we will get what? Minus I. That's it. So minus I is a simplified form of this value. So I have substituted this given question is this. So I have written minus I the whole power n square. Now we have to find the smallest positive integer n. See, positive integer n, that means what? Natural number, simply we can say. So we have to substitute n natural number, it should be least value. So natural number first value is n, so I start with n. When I substitute n equal to 1, I will get minus I whole power 1 square 1. So minus I whole power 1 is minus I. It is not equal to 1. They are asking that should be equal to 1. So I move on to second, n equal to 2. When I substitute n equal to 2, I will get 2 square. So minus I whole 2 square is minus I whole power 4. So minus 1 whole power 4 into I power 4, it will become I power 4 is 1. We know that this is a proof you might have studied. So I power 4 is 1, minus 1 whole power 4 is 1. So 1 into 1, 1. So for n equal to 2, the given expression reaches the value of 1. So option A is the right answer. That is answer 2. We will move on to the next question. The value of x satisfying the equation log of sin x base cos x equal to 1 where x is 0 to pi by 2. Why they are telling 0 to pi by 2? That means the sin and cos both values are always positive in the first quadrant. So the log inside negative value is not defined. So log is defined only for positive values, so that they are cautioning it. It is never going to be negative, right? Now we just have to find the value of x, right? Simply. So I have written here log x base a equal to b. Simply, if it is log x base a equal to b, it is a little small letter, we will make it big. So now it will be visible now. Now log x base a, log x base a equal to b. If situation is like this, we can simplify like this: a to the power b equal to x, a to the power p equal to x. We can write this form. We can remove the logs anytime. If you want to take log, so it will be log x, this will come to the base a equal to b. We can convert one form to another any time. So I'm going to use this to solve this sum. So this is a given condition. So I will write sin x equal to cos x whole power n in this form. I will write removing the log. Now cos x whole power n is actually cos x. So sin x equal to cos x means sin x by cos x equal to 1. So we will get tan x equal to means tan when 1, x equal to pi by 4, it is 1. So option C, answer pi by 4 is the right answer. We will move on to the next question. Next question, it is given del is the value of the determinant. One determinant is given. Then what is the value of the following determinant? They are asking. In this, we have written P in the first column and Q multiplied in the third column. P and Q are not 0 or 1. So that when it becomes 0, what will happen? The whole thing will become, so determinant value will become 0. So it is meaningless. So that this and this always going to be, we cannot compare. We are comparing with these. Because of Q, it becomes 0. Not because of A1, A2, A3, C1, C2, C3. So that they are cautioning. Okay, it cannot be 0 or 1. Okay, now we have to find the value of this. This value equal to del, it is given. So in terms of del, we have to present. You look at the options, it is given that P delta, Q delta. Okay, to use this, I have the one property of a determinant. What it says, if each element of your row of a determinant is multiplied by a constant. So row or column, here it is done in the row. So if it is any particular row is multiplied with the constant k, the whole determinant value multiplied by k. Now if you have a lot of practice, you can say the first column multiplied by k, so del will be multiplied by first column multiplied by p, so del will be multiplied by p. When I multiply this third column with q, del will be multiplied with q. So I can give answer as option D, pq del is the right answer. Directly we can say. For proof, I have written this. This is a given expression. I'm just multiplied with pq simply to prove it. Now I move the 1 by pq inside. First 1 by p into this, p will be cancelled, it will become like this. When I multiply 1 by q in this column, so q will be cancelled, it will go like this. So this is actually del. So answer is pq del. Okay. So option D is the right answer for this question. We will move on to the next question. The next question also based on binomial theorem, but the binomial theorem we are using application concept oriented. Now if C0, C1, C2, C3 dot Cn are coefficients in the expansion of 1 plus x whole power n, then what is the value of C1 plus C2 plus C3 up to Cn? This format is very familiar in any competitive exam. in India. Many competitive exam, general maths means they used to ask this question. Okay. Now, what is the value of this they are asking? So coefficient of this 1 plus x whole power. So simply I have written this formula. 1 plus x whole power n is nc0, nc1, nc2, x1, x power x square, nc3. You know this expression, right? Now we have to find coefficient only. We don't want variable x. So remove the variable. I'm just substituting x equal to 1. When I substitute x equal to 1, it becomes 1 plus 1 whole power n equal to nc0 value 1. We know that. Then wherever x is there, it will become 1 power. It will become, right? Wherever x, we just substituted 1. Now this 1 plus 1, 2 power n it become. When 1 goes this side become minus 1. Right hand side what will become? nc1, nc2, nc3 up to ncn. Simply we can write it as nc1 is actually c1. That is the format they are given. This nc2 can be written as c2. nc3 can be written as c3. Like that ncn can be written as cn. This is 2 power n minus 1. Okay. So this is a question asked. So final answer is 2 power n minus 1. This one is right and not this one. Okay. This they are subtracting in the power n minus 1. This is wrong. So yeah, 1 is coming separately, not in the power. We can see 1 is coming from here. So your answer is 2 power n minus 1 is the right answer. So next we will move on to the next question. So before moving on to the next question, please like our video. So when you like our video, then only the YouTube will suggest our video for the lot of people. So and share with your friends and relatives and subscribe our channel so that YouTube will we will notify you once we come to the live. YouTube will notify you and press bell button so that it will be useful. Next we will move on to the next question. Question number 14. A plus B plus C equal to 4 and AB plus BC plus CA equal to 0. Then what is the value of the following determinant? They have asked a question like this. So this expression, what is value of this? They are given two conditions, A plus B plus C, AB, BC, CA. Okay. Before starting the sum, we have AB plus BC plus CA and A plus B plus C. So to find A square plus B square plus C square, I'm going to use this formula. So AB plus BC plus CA is 0, so that 2y is 0. Here A plus B plus C is given as 4, so it becomes 4 square. From this I got A square plus B square plus C square equal to 16. I got it. Now next I'm going to expand this. This is a formula I'm going to use this. You know this formula we are going to use. We will use it. Now I'm just expanding this matrix determinant. So when I expand with the first row, so A into BC minus A square. When you put minus B, it will become B square minus AC. When you put plus C, it becomes BAB minus C square. Okay. Now when you go inside, this becomes ABC minus A cube. B minus B cube plus ABC. Plus ABC minus C cube. We got it. So it becomes 3 ABC minus A cube minus B cube minus C cube. Now we will get, when you take the minus common, you will get the formula pattern. So left hand side is coming. So I have just to substitute the right hand side here. This is minus outside common. Now we know A plus B plus C is 4. This A square plus B square plus C square is 16. This value 0, it is given directly. So 16 minus 0. When I multiply 4 into 16, 64, this is minus outside. So minus 64 is the right answer for this question. It's a very easy question you can do. Option B is the right answer. Next, we will move on to the next question. In the next question, it is a set language based question. It is asked, the null set is a subset of every set. Yep, when you write the subset, we will get the null set they are telling actually. Okay, so if you are having set like this 1, 2, 3, this is a set. If you are writing subset, what will happen? 1 separate, 1 set, 2 separate, 3 separate, and 1, 2, 2, 3, 1, 3, and all this together, and one null set. You know this very well, right? When there is 3 element, what is the power of this? Is called power of sets. How many power sets we will get? 2 power 3 number, 2 power n power subsets. N is 3, so 2 cube is 8. We got 8, right? 4 plus 3, 7 plus 1, 8. So whenever you write the subset, we will write empty set always. So null set is a subset, every set. Whatever the set, we used to write the subset. Okay. So this is a right statement. Every set is a subset itself. Okay. For this set, while writing subset, we are writing this also. So every set is a subset of itself. This is also true. And if a set has a 10 elements, then power set will have 1024 elements. It is true. We know that for 3 elements, power set is 2 power n, 2 power k3. If it is n is 10, that means 2 power 10. 2 power 10 is what? 1024. This is 1 kilobyte, right? Kilobyte, megabyte, everything we are using. This 2 power 10 only. This 1024, 2 power 10. We know that. So this is also correct. So all the three statements are true. So which option we can choose? Option D is the right answer. So here I have given some definition for you. Power set of x is a set of all subset of x. Power set means while writing all the subsets. Here I have mentioned that whatever I have written in the diagram. Here modulus x, the symbol modulus x means the power set of x is actually a number of elements in the x is n, means power set of x. P of x modulus means number of items is 2 power n. That's it given. Okay. Now we will move on to the next question. Next question. Consider the following statement. A function f such that z to z. Z to z means it is actually integer. Okay, integer, we know that. Integer means this is integer like this. Minus 3, minus 4, minus it keeps going like this. Here minus 2, minus 1, 0, 1. These are integers. Here also integers. So we are writing relations from integer to integer. Okay. Now what they are telling, 1, 1 as well as onto. The question is it 1, 1 and onto? So this is a little theoretical subject actually. This is what is 1, 1 function, it says. It's called 1, 1 function, a distinct element of A as a distinct image in B. Okay. 1 will have C as an image. Okay. 2 will have A as an image. 3 will have D as an image. So one object of distinct image, then we call it as a 1, 1 function. Okay. And onto function. What do you mean by onto function? Range of f is equal to codomain. That means whatever the elements in this sequence, that is in the codomain. In the codomain, all the elements should be a image of any one of. All the elements should be a image of any one of the elements in set domain. Okay, these elements. It should be belongs to any one of image of any one element in the first set. It cannot be simply left without related with any element. So it has to be image. So all collection of images called, we call it as a range. So when we say no element is left unrelated with the first set, that means range and codomain will be coincide. That case is called onto function. Okay, so you know that very well. Now this function is 1, 1. We can say 1, 1 related with. This is actually many to 1. Okay, here many elements related with 1 element. Here 2 elements, 2 and no, it is 1, 1 only. Here right, 4 and minus 4 has a 16 as the image. So this is a many one. Okay, this is only 1, 1 image. And also this is onto. Why? Here no element is left without relation with the first one. So this is 1, 1 and onto. But look at here, this B and E are not related with the first set. So that this is not onto function, this is into function. At the same, this is 1, 1 always. One element related with one element. So this is 1 to 1. Okay, this is a basic idea. So based on this, they are telling integers defined as a is 1, 1 as well as onto. We will check it. Okay, that means every element related with next 1, 1. One element related with another one element. Second set. First set 1 element related with second set 1 element. Like that it keep going. What way? F of x equal to x plus 1. Okay. If it is x is minus 3 means when you add 1 it becomes minus 2. Minus 2 related with minus 1 because when you add 1 you will get this relation. When you add 1 you will get like this. Here it is an infinite set. It will be keep going. And we can make the relation infinitely without ending. So it will be keep going. This minus 3 will be related with minus 4 here. Okay, it will be keep going unending. So it is always true. This is 1, 1. And also here no element is left without related with the first set. So that this is 1, 1 and onto, it is true. First statement is true. Second statement, what it says, a function n2 is a natural number to natural number. F of x equal to x plus 1 is 1, 1 but not onto. They are telling. Let us see. Now natural number to natural number it is given. Natural number I have written. Now x plus 1 only. Same way they are relating. F of x equal to again what? X plus 1 only. So now what will happen here? So when x is, when you add 1, it will be 1 plus 1, 2. 1 related with 2. When you add 1, 2 related with 3. When you add here 1, so 3 related 4. It keeps going. So here 7 will relate with 8. It will be keep going. So it is always 1, 1, no doubt. One element related with the distinct element of second set. It keep going. But look at this. This 1 is not at all related with any element here. So it is 1, 1 but not onto. Since the range and the codomain is not coinciding. So that 1 is left here. So it is not onto. So this is 1 1 but not on 2. That's what they have also said. So this is also true. So both the statements are true. So that option C is the right answer. Both 1 and 2 correct they are asking. So both 1 and 2 are correct. So option C is the right answer. We will move on to the next question. So in the next question, it is given a trigonometry again. The number of integer value of k for which the equation 2 sin x is equal to 2k plus 1 as a solution is. So what is the integral value of k? Integer value. You know what is integer value? We know that minus 3, minus 2, minus 1, 0, 1, 2 like that. Any number you can say. Number of integers. How many integers will satisfy x? So that this equation has solution. This equation should have a solution. Okay. Number of integral solutions of k they are asking simply. Now we will solve it. 2 sin x equal to 2k plus 1. Now I am just putting it in the inequality format. How? Sin x is, we know that always it is related sin minus 1 to plus 1 its value. We know that. So to bring sin x, I bring this to right hand side. So it become 2k plus 1 by 2. When I split that term, it become k, 2k by 2, k, 1 by 2. So k plus half. So sin x is equal to k plus half. Now the sin x, we know that between minus 1 to plus 1. Okay, sin x must be between minus 1 to plus 1 always. So instead of sin x, I am substituting k plus half. It should be minus 1 to plus 1. And also k should be integers. Based on that, we can find the number of k value. Right. So subtracting half, since I want k, so I am just subtracting k from all the inequality. So it becomes minus 1 minus half, here plus half minus half, here 1 minus half. So minus 1 minus half minus 3 by 2, this minus half plus half cancelled, k will be coming. 1 minus half is plus half. So our answer k should be minus 3 by 2 plus half. But at the same time it should be integers. What? Minus 3 by 2 minus 1.5. That means. Then after minus 1.5 what will be coming here? After minus 1.5 here we will get minus 1. Then we will get 0. Correct? We will get 0. Like that. It is correct only. Correct? It is correct only. Here we will get integer value 1. But we have to get minus 3 by 2 plus half only. So we will take a half, 0 to half. So here what are the integers? Minus 1 and 0 only. The two integers are k there. So k can be minus 1, 0. Then only the given equation will have the solution. So that what will happen? So only two roots we are having. Two values of k satisfies. So that this given equation has a solution. So option C is the answer. Okay, right answer. Next we will move on to the next question. That is based on the discriminant quadratic equation again. If the roots of the quadratic equation x square plus 2x plus k equal to 0 are real, then option A, k less than 0, option B, k less than or equal to 0, option C, k less than 1, option D, k less than or equal to 1. Okay, it is given like this. Now here also we are going to use inequality so that then only we can get the answer inequality. Now what they are real, the word real, we know that to know the real roots to be real, we know that discriminant we will use, right? Discriminant only greater than or equal to 0 means it's real root. So this theory you know, you might have studied many times. Equal means two equal roots and also real. Greater than 0 means we will have the perfect square or not perfect square. Anyway, we are going to get two distinct rational or irrational root. Two roots we will get. So in these both cases we are going to get the real root. So when b square minus 4 is greater than or equal to 0, real root. When it is less than 0, it becomes imaginary root. You know that. So here b is 2. So b square, so 2 square minus 4 ac, here 1 is 1 into k is greater than or equal to 0. Then only we will get the real roots. So now what will happen? This is giving what happens. So 4 minus 4k. 4 into k. 4k greater than or equal to 0. When I take 4 common, it becomes 1 minus k greater than or equal to 0. 4 is go right side. So 0, 5, 4, 0. So 1 minus k greater than or equal to 0. So when k moves that side, so 1 is greater than or equal to 0. So k is on the left hand side. I can write this k less than 1. Less than or equal to 1. So option D is the right answer for this question. Next, we will move on to the next question. So before moving on to the next question, please like our video. So when you like our video, then YouTube will suggest for more viewers, and subscribe our channel and share with your friends and relatives, and press bell button. And PDF of this lecture PDF will be available for you in the description. Okay, so you can get it and get it downloaded, and you can repeatedly practice. Okay, so that we will provide this PDF, this lecture PDF in the description. You can collect. Okay, next we will move on to the next question. So n equal to 100 factorial, then what is the value of the following? They are asking, what is the value of the following? So this expression, this is completely coming in a log. We have to use a property of log to solve this question. Okay, so I have take n value 100 factorial, it is given. This also we are going to use. Okay, now we will take this. I just before writing going to the sum, I just explain some property of logarithm. Log AB, if it is like this, I can separate this log A by log B. Numerator one value, base value, denominator it will come. The common base value you can introduce anything. I have written simply C. You can put E, you can put 10, you can even put 2, you can put anything you want, but same value you have to substitute. That's it. This is a property of log. And another property, when it is addition, when log is in addition, when it is in addition, it becomes product. It becomes log AB PQ. That base value should be same. So we can use this property log AB base Q. So this is a sum given. I have rewritten the sum. I just have to simplify this. In the instead of n, I can use 100 factorial. So I have to choose a right option. Now I have written like this. Now I'm going to use the first property. This property. Okay. This property I'm going to use. So here this is in the log form. So I'm writing it a log n base 2. I'm introducing the common base here. Similarly, it becomes log n base log 3. This log n base 4. Log n log 4, either log n log 5, here log n log 5, this should be 5. Next log n log 100. Okay, now it is a reciprocal. 1 by A by B, we can rewrite as B by A, correct? Directly, it will be reciprocated. So I have reciprocated every term. So this log 2, log 3, log 4, log 5, everything goes to numerator up to log 100. It went to numerator. Look at the denominator, everything same. So LCM is log n. So I can just add LCM. And numerator, when base is same, numerator you can add. When you add them, what will happen? We have to multiply the values. So I just multiply 2 into 3 into 4 into 5 up to 100. So into 1 is missing. Even if you want write 1, it will not affect the result. So 1 to 100 product can be written as 100 factorial. You know that. So numerator become 100 log 100 factorial. Denominator log C n is there. Here this n also. Separately it is there. Again I'm reversing my property. If from here to here I'm reversing. So numerator denominator, this log values I'm writing together. So denominator log value go to the base. So it becomes log 100 factorial base n. Now what will happen? N is 100 factorial, it is given. I'm just substituting log n instead of 100 factorial. So log a base a is 1. So the final answer will become 1. So option B is a right answer for this question. Next we will move on to the next question. That is 20th question. In this it is given z is equal to 1 plus I, where I equal to square root of minus 1. Then what is the modulus of z plus 2 by half? Again complex number. Okay. Now usual we know that it is clearly given z equal to 1 plus I. I'm just substituting and simplifying. Look at this. We should not forget to use a modulus. After simplifying this, we have to find the modulus value. Okay. So z plus 2 by z is 1 plus I, 2 by 1 plus I. Now I'm just rationalizing a denominator. Further multiply and divide with 1 minus I. Now a plus b into a minus b, a square minus b square. So it becomes minus I square. I square is minus 1. So 1 plus 1, 2 here. Numerator 2 into 1 minus I. This 2 cancelled. So plus is outside. So what will happen? 1 plus I plus 1 minus I. In the next step, what happened? Here this plus I minus I cancelled. 1 plus 1, 2. Okay. Now we got 2. 2 is a positive value. Modulus also positive value. If you are taking square root of 2 square plus 0 square, it is going to 2. Okay. 2 square root 2. So in the modulus 2, very simple, it's a real part 2 only. It will be coming here. So from origin distance also 2. Absolute value of the modulus of this is 2. So option B is the right answer for this question. So in this video, we have discussed 20 questions from this. Actually, in this paper, UPSC has asked 120 questions from this. In the next coming videos, we will be doing remaining questions. We are going to complete all the questions completely. So please support our channel, subscribe our channel, and like and share with your friends. We are going to load live videos for our pro UPSC, this NDA program, so that you can use it. Okay, and moreover we are going to attach this PDF, this lecture PDF in the description. You can download and practice it. So competitive exam is always a repeated pattern. Okay, but repeated pattern will be little more, that's it. So a lot of things will be there in the repetition, that's it. But anyway, they are going to ask the repeated only. So practice the previous questions thoroughly so that you can pass easily. Okay, that's all the competitive exam. Okay, we will see in the next video. Thank you for watching the video.